Hello, here's my presentation to the Ontario Energy Board for my proposal for 2030. So now going on to the current situation of energy supply in Ontario. By looking at the diagram on the right here, you can see that in 2021, most of the energy mix is predominantly nuclear, while hydro is also relatively high, and all other sources of energy are relatively low. And additionally, if you compare it to the graph on the left, which shows the energy percentage consumed by the rest of the world, you can see that Canada is far more clean than most places around the world, as it is more developed. Here now is a map of Ontario's power plants according to the IESO. As you can see in southern Ontario, most of the plants are things like wind, some hydro, gas, nuclear, and solar, as that's majority where majority of urban areas are. And in the north, it's predominantly things like biofuel and hydroelectric. But these hydroelectric dams are rather small, and they're things at like the end of rivers and such. And another important thing to mention is that the Pickering Power Plant, which is in southern Ontario, is set to fully close in 2025, which will reduce nuclear energy by roughly 14%, causing people and the government in Ontario to become far more reliant on natural gas and other fossil fuels. So here now is my proposal for the OEB so that Ontario may reach at least 50% renewable energy by the year 2030. So as you can see here, some major things is nuclear is down 14% because of that Pickering closure, as I mentioned earlier, and additionally hydro is up quite substantially as well. Wind and solar are also up quite a bit, and natural gas is going down. And then if you calculate all of this, 54.6% in my proposal is going to be renewable energy by 2030. And I'll explain this how this all works later on. So now onto an overview of these renewable energies. So how does hydroelectricity work? So first, water is stored in a reservoir, and then next, it's forced down like a chute, and then the water falling causes turbines to spin, which in turn, because the turbines are spinning really fast, it turns the kinetic energy into electricity, and then the next step is then the electricity that's produced is exported to a grid. Going on to some of the benefits and risks of hydropower. Hydropower is very renewable and sustainable, and you'll see that this is an ongoing trend with the other energies I present to you today. Additionally, there's always going to be a constant flow of water in Canada. They're quite long lasting despite their large initial investment. Now, some of the cons are there are many environmental implications, and they can block waterways that are important to significant groups. Um, and also, as I said previously, there is a large upfront cost. So now, how does wind energy work? As you can see in the first panel, the wind energy is moving, which turns these massive blades and rotates them at a very fast speed, which causes these turbines inside that little box at the top to turn very fast as well, which then produces energy. And then this is then transformed into energy here in the third panel, and then it's in the fourth panel here, it's the electricity joins the grid and is distributed to our homes. So now here's some of the benefits and risks to wind energy. They're fairly expensive to set up, but once they do get set up, there's a relatively low operating cost and maintenance. Also, they can be built in rural areas easily, giving access to energy for people not necessarily in urban settings, although most of the population is in urban settings. Now, some of the cons. It's very dependent on wind, and wind is uncertain, so its production of energy is not always guaranteed. It also requires a very large flat space to produce these turbine farms, and it also can impact migratory birds because sometimes they fly into them. So now going on to how solar energy works. So sunlight contains these tiny particles called photons, and when it hits these solar panels, which are usually made of silicon. It causes these atoms, as I said, most normally silicon, to excite rapidly, which in turn creates a slow electrical current. And then copper wiring leads it to like a general area, and then it's later then packaged out to a general grid. So here now are some of the benefits and risks of solar energy. Solar energy, while it can be expensive like everything to create, once they're up and running, it is relatively low maintenance cost. And additionally, besides electricity, it can also be used to create heat. Now, on to some of the cons. It's very dependent on sunlight. Like wind, it's not always guaranteed. They require lots of space, and some materials needed to manufacture these panels have serious environmental impacts as they require like very large mines. So now I will speak on how I plan to implement my proposal. Here is now a cost comparison of hydro, wind, and solar farms. On the rows here, you can see the cost per kilowatt hours in cents, the cost to create a new plant or individual unit, and the efficiency. So starting off, the efficiency of hydro is quite high because the energy from it is simply produced from water falling, so it's easy to capture that energy. Whereas um, wind turbines cannot capture all the wind that passes through it, which um, means it's not purely efficient. And then finally, with solar farms, it's most silicon-based solar panels, which are most common, are only 15 to 20% efficient because most of that energy being captured is also produced into heat. Firstly, as part of my proposal, I want to build Ontario's largest power plant for 2030. I plan to build this on the bottleneck of the Albany River as it flows into James Bay. And I chose the Albany River because it's the second largest river in Ontario, and it also has very strong currents, which is very important for creating a hydroelectric facility. Additionally, due to it being so far north, it allows for easier access for electricity for people in northern Ontario, as many people in the north are relying on natural gas especially. But still, as I will explain later, it will still allow energy to reach urban areas. And these figures I said in this first dot jot here are based on the Robert Bourassa Dam in Quebec, which is also located in James Bay. So it gives a very close approximation as it is quite hard to build a hydro plant this far north due to transportation and various other things. Now on to my implementation for my wind and solar farms. Starting off with wind, I plan to build two new farms, approximately 1,000 wind turbines each, located along Lake Huron's coast, as there is strong wind currents there, and additionally lots of space, and many other wind turbine farms near those locations. And for solar, I plan to build one major farm located closer to Niagara along Lake Erie, as the more south you get in Ontario, the greater the sunlight is. Another important factor of my proposal is the infrastructure that is required to make this all possible and so that people can access my energy that I plan to create. So starting off, one of the main reasons I have my wind farms and solar farms so far south is due to there already being established transmission lines there. So there's no significant upfront cost to building these facilities. While on the other hand, my hydro plant here, which requires major transmission lines, is over 170 kilometers away, just as the bird flies from these major lines. So there will be a substantial cost to creating this. And also, another important factor to note is that as you go farther up, the land becomes more harsh and harder to traverse. And it's also far away from urban areas, so the cost of creating this is quite substantial. To close off, I want to give you an overlook of my proposal. I plan to create 27.3 terawatt hours annually, and I want to increase renewable energies in Ontario by 19.2%, and the cost of this will be $21.1 billion, and additionally excluding things like operating costs and infrastructure that will be required. Thank you for listening.